Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and electronics. How's everyone going today? This is a test with a new microphone and a new setup here with the setup I have with OBS to see if it is working correctly. And I hope that the sound is good. It doesn't appear to be good. Well, we'll see if anybody joins. So I'll play this back and do any kind of audio issues. So if I go to the main overhead camera, hey Tiago, is the sound good? I'm trying a new microphone. So if I go to the main overhead camera, I have that view, and then I also have set up, I have a web camera in the corner that I can use the web camera on. That seems to be working. Then I have that monitor in the corner. Then I can also do that monitor large. Okay. Then I have that camera. That camera's small with a border apparently. Then we have the microscope. So far so good. And the microscope's small sized. And then we have a list of all my test equipment on the bench. So we're hoping this sound is good. And then we have the different softwares. So I'm going to pull up the scope software and see if that tends to work. Because that was the issue. That was one of the issues I was having, was the scope software was not displaying on the screen for more than a few minutes. And I was having issues. So I'm going to get my scope out. I'm going to add it to the window. I'm going to do the screen capture. Okay, so if I press the scope button, you should have the scope on the screen. So let's give it a test. Let's take off the cursors and we will zero out that. And we will use this rat's nest of a board here. Yeah, I can pop the volume up a little bit more here. That's not it. Cancel. Advanced audio. There it is. Okay, I can do that to the audio. Is that any better? Yeah, I think I can do that. So hopefully that's a little bit better. I am talking a little bit lower. I'm trying not, because I had to yell before. And I'm not getting into the red on the audio meter. So I have to pump it up. It's a lapel mic here is what I'm using, because I got tired of wearing the headphones. So I might need to plug it into the microphone jack. Right now it's got an adapter into the headset jack. So I'm not sure if that is going to affect it in any way. So let's check. So that comes up on the screen. Let's check this software while I hook this up here. That's not the right cable. Let me grab the right cable. I'm going to get me some power. And we're going to put the power on the screen too, just to make sure that works. And let's check power. Yay, power works. And we are on channel 1. So we have power. Back. Okay, I'm going to have to put an audio filter on there. You're probably hearing the background of the scope. It's probably what's being picked up. I'm going to play this. I mean, this is a test stream, so I'm going to play it back and figure out what the audio filter needs to be. Maybe Phil can help me with the audio filter. I'm going to turn this on at 9 volts, turn on that. And this is now working, and I'm going to take this lead and plug it into the ground line, and I'm going to stick my probe onto this output here. And that should be channel 1. Why am I not getting... There we go. So now I'm going to bring that down. And that is showing on the screen. Okay, so this is... Wow, it is really slow when it's outputting the data. Hey Phil, how's it going? Yeah, I know. I need you to help me set up the microphone. I got a new lapel microphone. I need you to tell me how to do the background noise thing. And yeah, the fan is coming from the oscilloscope. Is probably louder now. Yeah, so I thought it was going to be just a plug-in thing. So did the scope crash? I believe the scope crashed. Nope, it didn't. That's good. Okay. So the scope is working. Let's see if we can test a capacitor discharge. Yay, test the capacitor charge and discharge. So, oh yeah, that would be fantastic, Phil, because that would walk me right through it. Because I like this better than having the headphones on, and I had to pump the decibels up in OBS to 10 to get it even doing good volume. So I'm not real good with the audio. So that seems to be working on that. Let's see if we can capture this when Alright, so that's, why is that high? Oh, I'm at it before it. I want to come out after that. So I want the output, which is next to it. Okay, so if I go into single trigger mode, and then I pop that, boom, I got it. Okay, so it's capturing. That is capturing with an oscilloscope. I just captured a single pulse from a rotary encoder that is highly filtered. That is highly filtered. So if you look at it before filtering, where is it before filtering? If I put it here, I put it in single. There, that's before it's filtered. It's very dirty. You can see it on the screen how dirty it is. If I zoom in on that, you can see that there's a lot of secondary pulses, and then there's a ramp and stuff. And if you look at that, and then if you come in here, let's just leave that hooked up, and let's plug in channel 2 and see if we can get 2 channels to display. Let's go to channel 2 and hook this up to ground. Hook this up the ground here and see if we can get dual channel display on here. So I'm going to come into the aftermath of the filtering. So this is going to be inverted and filtered. So hopefully we can catch it on both. There we go. So you can see the yellow is the input, and you can see how the filtering through the capacitor and resistor through the RC circuit, and then inverting it, how I have a nice crisp signal. And when the input has the ramp up at the end, it actually just drops back down. So I'm actually getting a cleaner signal as an output, as a pulse. So that is basically how this works. Is I take a negative pulse and I turn it into a clean positive pulse and use it as a data or clock signal. I want to say that that's the data line. I think that one's the data line. It's hard to compare the two. But if you take the two outputs, so that's the other output, and I go to single trigger, this should be, yeah, see, of course it came out. So if you look at that, you can see if I lower this one down to match that one, they match, but they're out of phase. So let's go ahead and put it back up so you can see. So as the clock goes high with this orange, with the purple, as the clock goes high, the data is still low. But if it was reversed around, the data would be high before the clock goes high. Then when the clock goes high, it sends a 1. So currently, if the purple is the clock, when it goes high, data is still low. So it will send a 0, and then it doesn't matter what happens at the end there. And if you look at what is the total time on cursors, let's check out the total time of the width of the window is about 9.8 milliseconds. So 10 milliseconds basically. But if you take the whole cycle, it is about 29 milliseconds. But if I come in here and I go to single and I go boom real fast, you can see I have a bunch of info here. Let's put that in more in the center of the screen, and let's lower to, and then there you can see it, and I can zoom in on that. So this is, this is what the oscilloscope can do for you. You can capture multiple signal points. Hey RB, hey Micro Mage, how's it going? Oh Micro, you're up early today. So I'm able to capture multiple points, and currently I have 2 points on there. Most people have dual channel oscilloscopes, and that is, it's fine. You can do a lot with a dual channel oscilloscope. This oscilloscope happens to have 4 channels, and then I also have a logic analyzer on the shelf over there that allows me to add 16 more channels, so I can theoretically capture 20 channels of data. So, and that's what I intend to do with some certain chips on the Nintendo Switch and get readings and data from them. But now that the scope works on the screen and there's no more issues with that, I can proceed with making videos using the oscilloscope. So I'm going to take the scope off, I'm going to take power off, and I did not want to turn that off, but okay, wrong button. So we will close power, leave the scope open for a bit, and we will bring in the meter and see how that looks. That's fine, Micro, that's cool. We've gotten a nice boost in subs thanks to the coder. We really appreciate it. Anybody that comes over from the Coder's channel, that's cool. Also check out Micro Mage Repair too. Let's see. Why is my meter dead? Oh, I hate it when it does this. Okay, add instrument. That's the one I want. You know, the one downside to having all singlet gear, they're all compatible, so that's the upside. But when you try to connect to the individual softwares, all the connected units come up. And if you click on the wrong one, you have to restart a bunch of stuff. So there's the meter. I chroma keyed it out, so all you're getting is the meter. So it does look better. Let's turn that channel back on, and let's take some measurements here. Now let's look at the delay in my meter. Checking a pulse that is very slow. So we saw the pulse from the clock on the oscilloscope. That is, well, let me just check the pulse on that clock again. So we will put the scope back up, and now it doesn't want to work. Let's scope. There we go. So we will turn off channel 2 because I don't want channel 2. And then I will stick my probe on the clock signal, and we will put it in single trigger, and it triggered, and single. Okay, let's do it single, and let's why am I not capturing this? Millisecond. So I changed my time scale. Am I not sticking it? Am I not probing the right? Okay, let's change the time scale to 5 milliseconds. Milliseconds. This will not single trigger. That might be why. There it goes. So there's my pulse from my clock. I had my this is a threshold voltage, so it was down here, set below, so it didn't trigger. It needed a positive voltage, so I just moved it up so it triggers at 320 millivolts. So on the side of it. So let's check to see how long this pulse is. I have a high on this. So this stays high for 73 milliseconds. It's pretty good. So we're going to see if we can capture that, if the meter's fast enough to show me how many volts is it. Y. Let's see here, how many volts is it? 0. So it's like 3.6 volts roughly. So 3.6 volts. So we'll see if the meter can measure 3.6 volts. So it's just there it goes, and then it stopped, and then it's just going weird. Yeah, it's just acting weird. So it's 3.6 volts for what was it, 73 milliseconds. So it's doing this up down, and I'm not able to capture it. That's why the oscilloscope is so handy. Oh, wow, that's pretty good, Phil. You're doing it pretty good. Yeah, Phil dislike. That's funny. So, we can actually change the refresh rate of the meter to fast. So, if you could probably hear my meter clicking. So I changed the refresh rate to a faster refresh rate on the software, and now you can see me capturing that, but I don't like what that was doing to my meter. So even when I back it down, it still reads it, but you have to be careful when you're trying to read a voltage spike on a data line. If you don't have a fast sampling meter, if you have just, a handheld meter, like here is a medium level handheld meter here. This is medium grade. These are old. I had these for years. Let's unhook that from there, and let's put this on volts DC, and let's plug it in and see if this can do it. So this one doesn't have a speed range, but you can see it flickering, and you really don't have any idea what's going on. It's going to 3. You can sometimes put it on min-max. So it maxes at 3.3. So, you can make it a way so that you can capture it. And then you can min it is 800 millivolts. So you can min-max it on a meter like this. If you want a meter for a home lab, I recommend these Astro AIs. This one is the WH5000A. This is a very good meter. It measures capacitance. I believe you can measure transistors. Yeah, it has HFE for transistor measuring. And it comes with a bunch of probes and stuff. It has diode mode, all that stuff. These are good meters. I have 2 of these. I don't use them anymore, but they're still really good meters. If you want something that has scope ability, let's see if I have one here. Yes, I do. So these were actually a gift, and these are Lumini. These are graphical meters. They supposedly have an oscilloscope built into them. I have never gotten it to work, but we're going to go to volts DC. And this one has a faster sample rate, so you're going to get to the 3 volts. You can also do your ranges and things like that, but if I go to display, doesn't like display button. Doesn't like that either. The other thing about this one is the beeping. Okay, that put me in auto mode. Puts me in hold. Yeah, so I'm not sure how to get it into. That's out of auto mode. There it goes. So that's in graphical mode. So if you just need to test a logic signal, these are pretty cheap and they do work. I don't think you have a whole lot of, things you can do. No, you really don't have a whole lot that you can do, but they do, they will show you a signal that you're getting, and it is a full function meter. So they are, there's something for a meter for, a scoping, because not everybody can afford a big scope or a benchtop meter or, things like that can capture at high speed. I was actually surprised that meter could capture that in no scope mode. So I don't know if it could capture anything faster. I don't have anything faster set up to be captured. So I'm going to stop the meter so I can clear my screen here. So, oh, that's going to mess me up. I have to close it now. Okay, that's closed. So, well, 3 likes. Doesn't say any dislikes. It's always a good thing. So, I am going to end it here. As I tested everything I set up with the thing. Oh, let me just check my slides. Yeah, that one works. That one works. And the intro screen works. So that is that. I made an issue on my Stream Deck. One of the buttons is backwards, but I'll fix that. I'll sort that out. But everything seems to test out. A little bit of audio background noise and the lower volume. So yeah, Phil, if you could help me out with that, I would have greatly appreciated it. I'll get with you after the stream. But thank you guys, and a little bit of oscilloscope testing and some different meter options. Didn't plan on that, but it popped in there. So have a great day.